Hello, everyone. Sanjin here with Stuffy again for another set of PicoCTF walkthroughs. We're going to be doing PicoCTF 2022 challenge. What you've just seen are the challenges we're going to cover on the previous slide. And before we start, we just want to cover some ground rules. So please try every challenge first yourself. And don't be afraid to get stuck on it. I mean, if you spend an hour and a half on a challenge, not being able to solve it, and then you come to us or anybody else for a walkthrough, like, you're going to remember the walkthrough you learn a lot better. And even if you have solved it, please, whether it's ours or other people's, do check out walkthroughs to give you multiple perspectives on each challenge. Sometimes, like, Stuffy and I can solve things in completely different ways, and it's always interesting to see how that works. Now, Stuffy is going to be doing the first, I think, 5 or 6 in web exploitation. So take it away.
All right. Okay. So the first one we're going to be doing is Roboto Sans. I believe this is in the web exploitation category. So we're continuing with the last video that we did. So Roboto Sans, right off the bat, without doing anything, the Roboto gives me a hint that it's probably something to do with the robots.txt. But let's go ahead and figure out if that's true. All right. So we got an actual website, which is kind of interesting because usually they just do a
I've seen this in another challenge. We did this.
Oh, have you?
Yeah. I'm pretty sure what we did.
I think you're right now that you say that, but because some of the links don't work, if I remember correctly. Okay, so think you have seen your flag, or you want to keep looking. Now, okay, so
can I stop you with a couple of questions?
Yep.
So we've covered robots.txt, and robots.txt is supposed to tell the sort of Google and other indexers where not to look, because, you know, maybe it's sparing the energy.
Yep.
Do you ever, on a normal legit site, see anything other than the disallow specific URLs? Like, if you see some other stuff, is that weird?
Oh, no, it's not weird. There's a lot of different things that they can keep in there. Now, keep in mind, so I don't know if you ever heard of the iceberg of the internet. So the iceberg of the internet is the internet that we see is about this big, right?
Right.
And then the internet that people use is like this big. Now, what they mean by that is a lot of times, a lot of resources you're using are on the internet and you could go directly to them. For instance, like this CGI bin, we could go to that, but it's not indexed, meaning it's not on Google. It's not on anything because of these robots.txt files. So sometimes there'll be databases, there'll be different things like that they just don't want indexed. It's not necessarily a bad thing or that it's got some sort of crazy data. It's just something they don't want indexed because it's a waste of resources for everyone involved. So a lot of times what you're seeing is just kind of gives us a little bit more of a attack vector. So for instance, this WP admin, if we went to it, we can go to it right now, you'll see this is just we just didn't know this existed, and they probably got rid of it. That's why it's not there. So it's just
WP
something
is like WordPress, right?
Yeah. So they probably just put it in here and then, or it was here by default and they never got rid of it. But yeah, it's just a way of telling people, because for instance, if you had a website, right, there's certain things you want people to see. You want to direct them to your homepage, to your, the information on the website. You don't really care that they can go and find, your employee directory or whatever, right? But as a hacker, we find big interest in those type of things because employee directories, especially for companies that are public, can be very useful for us because now we have a target list for phishing attacks, right? So that's the type of stuff we're looking for in here, is stuff that just isn't indexed that we can use to our advantage.
The other question is like right there, what I've circled. I mean, that's clearly encoded text of some sort.
Yep.
Is this in itself like, that's got to be flag related instantly because you wouldn't see that normally, or
I would say yes. I've never seen, excuse me, encoded text like that in here. There's no reason for it, unless you're trying to hide something, right? That's the whole point of encoding, is either to, encoding has a couple of different purposes, but the robots.txt, like I said, isn't supposed to be a security feature. Some people use it as a security feature, maybe a bad admin or something like that, but you're not supposed to have the sites that you actually want to hide, for instance, like your admin page and stuff like that. Those might be in here, but there should be security features that still stop someone from getting through that page. So this is not a security feature. It's a convenience feature and a resource feature. And because of that, anything you put in here, just be fully aware that someone can still get to it very easily.
Got it.
So go ahead.
No. I was just going to say, now that we got the encoded flag, what's next?
Yep.
CyberChef?
Yep. So CyberChef it is. And one thing that I ran into the first time I did this, and this is just from messing around, I took this whole encoded text and tried to put it in there, and it didn't work. Now, that just tells me, okay, let's do line by line and see what happens. But the first thing I wanted to point out that I didn't even explain is I just grabbed the base 64 and brought it over. And if you guys watched our last video, you know we talked about base 64 and how to tell sometimes. And the big giveaway here for me was these two equal signs at the end. So base 64 will fill space at the end of text if it needs to with equal sign. So it's kind of like filling white space, if you will. So the equal sign, two double equal signs at the end, almost automatically tells me it's base 64. So the first thing I did was just grab these, just put them in here and see what we get. All right. And you can see we get flag1.txt JS/myfi. Okay. So that tells us we're on the right path, but that doesn't really give us, the first thing I would try is probably to go to flag1.txt and see if that's a site. So let's copy this one first and then try flag1.txt. Since we know that's okay, so it didn't find it, so that's not it. So let's go to this one. Okay, and you can see it's JS/myfile.txt. So let's go to that. So if we get rid of the robots.txt and we do JS/myfile.txt, that's right. Yep, myfile.txt. Okay, and there we go.
Whoa.
So it was pretty easy to decode the line. I don't know if they were trying to do a base 64 challenge or a robots.txt file challenge, or if they were just trying to show you the mixture of the two. But that was pretty much pretty simple and pretty easy to find, but also really important to know and understand that the robots.txt file is there to find a larger attack vector. And there you go.
I mean, it is really, two of the themes being combined. We've seen a lot of challenges that involve base 64. Your tip with equal signs is, I think, going to save a lot of people a lot of time. And yeah, robots.txt, if you do see some encoded or encrypted text there, I think that's just chuck that into CyberChef. Just do it if you ever see that.
Give it a shot. I will say this, there are some admins, site creators, whoever's making it, right? That will put stuff in there, kind of like not just notes themselves, but they know people are going to look at it. So they will put stuff in there like, I think like Nmap and stuff like cyber aware people will put like little things in there like, hey, don't look at this and stuff like that, like trying to be funny and stuff like that. So there are some interesting stuff you'll find in robots.txt files.
I'm finding something interesting in your profile. You've done none of the easy challenges. You've done a lot of harder ones. Yeah.
For a while, I actually wasn't putting the flags in because I wanted that way. If we do it, you can see it, because I didn't realize you could just keep entering the same flag, because on some of the other sites, it doesn't do that. So I wasn't putting the flag in, but all right. So forbidden paths is the next one. So this is one I don't think I put the flag in, but all right. So can you get the flag? Here's the website. We know the website files live here and the flag is here. Okay. So this tells me just kind of the mindset that I'm in when I read this. The first thing that's interesting is you notice when we've done any other websites, they haven't given us the file structure. So that kind of tells me there's probably a reason they're giving me the file structure and telling me where the flag is. So I probably need to know how to go from this file structure to this flag. So let's go to the website and check it out. So we can close that one. Okay, web e-reader. So, okay, so we got to read the file name. So it gives us a couple file names here.
Can we
see if we can?
Yeah.
Yeah, let's see if we can do divine comedy.txt and see if it gives us. Okay, so it's an actual, they're actually giving us some.
Dante Alighieri.
Wow. Geez, this thing's gonna scroll forever. So, okay, so we can actually read all these, but the one that strikes me there is they give you a little hint there. There's 2 dots up there. So if you guys know how to traverse Linux, if this is a Linux server, right, we would have to do a little bit more enumeration, but a lot of web servers are Apache and things like that. So from here, we just would try, it's obviously opening this. So let's go ahead and try.
Stuffy, a little pet peeve. Yeah. Can you like zoom into like 200%? Because like I want the people to see the symbols. So like just to zoom on the Chrome. Yeah.
Gotcha.
Click Control Wheel or whatever. Like get us 200.
Yeah. There we go. Is that 2? That's it.
I can't see any difference.
Yeah, I can't either.
Just click on the website and scroll your like scroll wheel. How about that?
Yeah, that's what I'm doing. It's maybe the site doesn't have the function.
That is.
Let's go here. Yeah, it's the site.
It's the site.
Yeah, it doesn't have a function.
All right, guys.
Sorry about that.
If you're on a phone, I'll read it for you. How about that?
Yeah.
All right. Go for it, Stuffy.
Yeah. So if you know how Linux works, this is a pretty basic site. So if this was a harder CTF, because I know the CTF is easy, I know exactly what to do just based on some easy tactics. But if this was a harder site, first thing I would do is I'd probably go to inspect and I'd probably go over to the sources and look and see where they're getting these, they're pulling these from, right? And because if you see here, I'm not seeing any JavaScript or anything like that. That tells me I'm not seeing any back-end processes happen as far as when I type this in, I don't see it sending it to a JavaScript that is then reaching out to a database or anything like that. I just see straight code. So that tells me that, and you can see here, name equals read. So this tells me pretty much that it's just going to open whatever file is on that server in that directory. So that's pretty easy information because a regular website wouldn't do that, but this one does. So what we can do, if you know Linux, we can actually just push the dots and that actually takes us back.
So it's kind of like going CD space dot, right?
It's exactly like that. The only difference is this is my guess based on the what it's doing is when I hit read, it's actually catting that file or reading the file. So when I put this in, it's looking for a specific file path. Well, the nice thing about Linux is if you just keep doing .. you're eventually going to hit the root directory. It doesn't matter if you put,
let me stop you there for 1 second. There are no spaces. It is ..
Correct.
.. Yep. And so, yeah, if you're on a phone, it's .. and you're going straight into root pretty much.
Yep. So if you actually do the math, you can see that we need to go back 1, 2, 3, 4 directories to get root. Well, I went more than that just to show that you can go back as many as you want because once you hit root, it's just going to keep going back, which is nothing. So it's just going to stay at root. So we know we're trying to read flag.txt. I think it's just, is it just flag.txt? Yeah, flag.txt. So we can do flag.txt. And when we read it, what's actually happening is this is going back 1 directory, 2 directories, 3 directories, 4 directories. So now we'd be at the root directory, but then the other 2, it doesn't matter. They're just going to stay at root. And then it's going to read flag.txt, which is sitting in the root directory. And when we hit that, that's where our flag is.
Yay. All right.
Now, let's see. Boom. Perfect. Now, one thing for those of you that aren't familiar with this kind of directory structure and what the point of this is, right? So a lot of people ask, what's the point of a CTF? Because in real life, like, you're not going to have a flag you're looking for, right? No one's going to put a flag on their server and say, hey, come hack me and take this flag. So what we're looking for is we're simulating information that we grab. So one of the first things I would do if I could on a server is I'm going to grab the password file. Now this is in Etsy password, excuse me. And you can see I've already done it right here.
So you're going from the root into Etsy and from Etsy into what, like.
So, yep, I'm going into Etsy and then the password file. So the password file used to actually hold passwords. That's why it's named that.
Right. I was going to say, like, really, like that.
Yeah.
Is there anything that insecure? Okay. There used to be.
Yeah. So Unix way back in the day used to actually hold passwords in the Etsy file or in the Etsy password file. They obviously said this is way too insecure. We've got to stop this. So they stopped it. Now they're held in the shadow file, and the shadow file needs root access, which we don't have, but we can always view the password file, which holds the user accounts of a machine. So we can see this here will tell us all the user accounts, and it usually tells you the groups that they're in as well. Now, some admins will put in Linux will put groups, but if there's no groups that actually exist, it will just make a group for you that is your same name. So you can see that you'll see like mail and then mail, and then you'll see proxy, then proxy. This is the account name and then the group, but the group is just created
for the account,
just for that account. Yep. So you can see, even if we don't have their passwords, if there was 50 people on here, well, now I have 50 people that I can try to guess a password versus the one account that we knew about, which is root, because every machine has root. So this is the type of stuff that CTFs are simulating when they're looking for, is you're looking for actual information that you can use against someone.
Super. I mean,
all right.
We got 2 down. That was like the part that I found interesting is sort of the connection, like when they're showing you the folder structure, because this is going to occur in other challenges. You know, my first question to Stuffy was, and he's going to answer that soon enough, is like, can you list the folders in a website? And I think the answer to that is kind of sort of a little bit with some tools.
Yep.
They're not public.
Yeah. Well, so yeah, so there's definitely tools, and I'll show you that here in a bit. But on top of the tools, depending on what the website is, whether it's IIS, Apache, whatever you're running, they come with default settings, right? So they do have default folders that if an admin doesn't change, they will exist. The other big thing is, especially nowadays, is a lot of companies use website builders, right? Like GoDaddy.com and things like that, where they're just adding images and, you know, graphics and things like that. They're not actually typing the code and writing the directory structure for the website. So when you use cookie cutter websites like that, typically like the admin login page is going to be like admin login and things like that. So that's the type of stuff where you got to think about as well, is when you see something like that, you go, okay, this person probably didn't know much about IT. Therefore, it's probably easier to get into.
Yeah. I mean, especially like if you can hack one WordPress site, you could, like, it's probably worth the effort for a hacker, right? Like it might be set up to be 10 times more secure than the average Joe's custom website, except it's 1,000 times juicier target.
Yep.
Which maybe like it might actually work out that having a less secure custom site is safer than a more secure template site.
So the one thing I always tell people, because as a hacker, everybody and their mother asks you, you know, well, should I be worried? Should I be worried about getting hacked? And I always tell them the same thing. Unless you got $1 million, probably not that worried about it. Now, if you make an enemy, then you might want to worry about it. But for the most part, you're not.
If you have a crypto account.
Yeah, exactly. You're not valuable enough to a hacker to have him spend his time and effort, unless it's personal, you have money, you have to have some sort of value. So there's this like misconception that hackers are just all day long, just trying to hack anybody and everybody. Good hackers have targets, and the other hackers are usually on just looking to add people to a botnet. So they are just spraying attacks and hoping they work. So that's why Windows and people like them just tell you to keep your system updated, and it makes it 10,000 times harder, because when your system is staying updated, you're not the low-hanging fruit anymore. You're now harder to attack than Joe Schmo down the road who didn't update his system. So now those people that are just spraying attacks, they're going to skip right over you and go down the road to that guy.
Okay.
Hopefully that makes sense.
It certainly does. So secrets, this is the most exciting one. So tune in.
Yeah, this one's fun. All right. So we have several pages hidden. Can you find one with the flag? Okay. So let's go to the website, and there's a hint here. Folders, folders, folders. Okay. So that's a good hint. All right. So we've got a website here. It looks like a stock photo. So it's a stock site, about page, contact page. Okay. So we can go here. All right. So because they said folders, 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 that tells me we probably want to look at the folders, right? Okay. So already I see a secrets folder, which isn't normal for a website, right? That's usually telling me you want to hide something. All right. So let's look here. Okay. So let's see if we can go to the secrets folder. Secrets. And so one thing that I got caught up on earlier is you'll see if I hit enter here, or it's secret, not secrets, excuse me. If I hit enter, you see it just loads. And that's because this is a folder. So I need to actually close it with that / so that it knows it's a folder, not a file that it's trying to load. So now when I hit secret, you can see now we have another folder called hidden. So let's just keep going down the rabbit hole here. So we go to hidden. Okay, so now we got to log in.
Go back to secret, please. So you saw hidden in the sources. So wait, you only see what? One folder of the structure when you're inspecting sources? Like, why didn't we see hidden when you opened up the secret?
Because we haven't gone there yet. So once we go there, we're building out the structure, right? It's the same as like, so I'll show you. It's the same as if we go back to the home page. So our computer doesn't know this exists yet.
Right.
So for instance, if we go here, right, we don't see anything about the about page or the contact page. But if I go to the about page, now it pops up under the secret assets,
right,
because now it knows about it, right? When I hit the contact page, now it knows about it. So that's basically what's happening is your computer is seeing the next tier, but it's not going to automatically start crawling into those tiers without.
So let me point out,
oh, sorry.
No, you could stay there. I want to point out this, if you look at this in the sources, like this, what Stuffy's saying, and this is really important because I had a bit of a misconception here, right? I always thought this is the folder structure of the website. And I always thought like, maybe there's some special settings in these folders that keeps making them invisible to the folder structure. But no, this isn't the folder structure of the website. This is just the mapping of where you've been. Is that like... It's not just where you've been. It's what is on this page, right? So what's like accessible from this page, what's being loaded on this page. So here's like the images. You can see that we still don't see the about and the contact folder here, or the pages here, even though they're under secret, because we're not accessing them here. We don't need to see them. It doesn't know they exist unless we go back to secret. So here's one what if question, right? What if this thing here, let's say right here, we accessed an image that was in a subfolder of secret. It was pictures. We would now see pictures because we're accessing an image from it.
Yep. So if it loaded on a page, anything like that, you would now see it.
Right. So basically you're seeing what that page, the folder structure, the minimum folder structure that page needs to function. So where it gets its files from.
Yep.
And if it gets a file, you'll see the folder where that file is in.
Yep. And that's why it looks like you said, if you look at a large website, it looks like this is the file structure because there's 50, 60 files loaded on one page. And that's pretty common because you have your CSS file, which is then reaching out and changing pages. Then you have images loading. Images are going to be stored somewhere. So now all the images loading, fonts and things like that. If you're storing different fonts, pretty much everything that it takes to build a website is being loaded in, has to be shown here because that's where the source is for it.
Right. And that's very important because like that is, I mean, you know, I've been messing around with this now. I mean, not for too long, for a month or so, but I had completely misunderstood that.
Yep. That's why we use the tool that I'm going to show you to actually crawl a website, because there are tools out there. I will tell you this. If you have a website in your domain that you're worried about, there are tools out there that you can use that will allow you to log in. They're like web app scanners and stuff that will allow you to log in with your credentials to that website and then scan, and it will try everything, right? It'll try to touch everything, any clickable links, and follow them, and it'll build out directory structure for you and tell you what's viewable by somebody if they do the same thing. Cool. And so now we found secret. We can see that there's hidden. So let's go to hidden. Okay, so now we have a login page. So this would be, this is obviously just a default login page. It probably doesn't even go anywhere, but this would be what a hacker is looking for when they're looking for directories. Typically, they're looking for the admin login page, because if they find that and I can brute force the admin password, or I know a user that is an admin, I can now log in as an admin to your site. So now you see after hidden, we have super hidden. So let's try super hidden. Super hidden. Okay, so now it says, finally you found me, but can you see me? And you can see here, like you said earlier, it's right there in the text, but you can also see it's right here as well. So however you find it, I found it this way just because I quickly highlighted it, knowing what they were talking about. And then you actually saw it first thing in the context here. So yeah, so it's however you find it, but there's the flag. We'll go ahead and put that in. Yeah,
Stuffy, this was honestly, you demoed this for me before we started recording. But this has been one of my favorite web exploitation CTFs we've done together, because like, being a teacher, especially sort of in coding and technical areas where stuff builds on top of another, like the most valuable thing you can do for a student is sort of point out a misconception they have, because like I thought I knew how that worked. I clearly didn't. And like, this is going to be, this is huge for me personally.
Well, like you said at the beginning, you will now not forget that because you made a mistake, if you will, even though it's not a mistake, but because you had that misconception, now you'll remember. So that's why we tell you guys to try this on your own, because if you had something wrong, you'll remember that, versus if you just went through it real fast and had it right the whole time. All right. So now I'm going to show you guys what, the same site, same everything, but I'm just going to show you a quick tutorial of like what a hacker would do on this site. All right, so let me pull it up here. So this is my machine here. We're going to use the same exact site. So I'm going to make it small here so that you can see that I'm using, I need this here. Okay, so all we're going to do is we're going to use a tool called GoBuster in this sense, but you can use GoBuster, DirBuster, they're the same thing. So if we go to GoBuster, I'm going to walk you through this command. I'm not just going to throw it up. So it's GoBuster's the tool. It's a tool that tries to it tries to walk through a website, meaning it's going to try every single directory. So it's got a list, and this list is the one that comes default on Kali, on Parrot, user share word list, DirBuster, which is another tool. It's just their word list. And we're going to use their small word list. Now, if you have the time, you could use a big word list and you could map out an entire website, and you could sit here and do it all day long. But just
to clarify something, maybe you could do this before you run this command, right? can you cat the word list? Because like I want people to see like what is it that it's trying? Because
and I'll show you what it's trying here. So we'll cat the directory list 2.3 small. So you can see this isn't a huge list comparatively. It looks big, but it's not huge compared to some of the word lists that people use. So you can see, like, let's go to the top. There we go. So we're looking at index. So index is obviously the first, that's always the home page typically in a website. Then it's going to look for images, download, news, full. So what it's doing with all these is it's going to try like contact, for instance. So we know we have a contact page, but is it called contact? It's called contact.html. So it's not going to find that one because it's called contact.html. But
if there was a contact, if there was a contact folder, it would map out that folder as well due to that list.
As long as it's named, as long as it's just named contact, because that's what it's going to try. So what it's doing is it's going to try like contact. And then without the HTML, do we get anything? You see, we don't get anything. So it's not going to find that. Now, the bigger word lists and different tools like GoBuster, Dirbuster will actually allow you to change all the word lists to like PHP, different things like that, HTML. So there's a lot of ways to do this. But basically, once we have that up, we'll go ahead. So with that, we've got the word list. We'll go ahead and run that command. And you can see we have the word list. And then the URL, the TAC-U, the URL is just this right here. And it's going to run. And you can see it's going to start progressing through. And you can see it does it very rapidly. So you're looking at, it's already done 1800. And that's because here's a negative status code. The 404 error means negative. It didn't find it. It's looking for the code that actually says it's successful, which is a 200 error, I believe, is what it's going to look for. And you can see right there, it found secret and it found the secret directory. So there's a secret page and secret directory, and it's going to keep going. And this will just run. It's at 7%, 8%. It's just going to run. And this is a very small list. Keep that in mind. So if I use the big list, this could go for hours, but you can see it found that secret real fast. And then from there, we could just keep going down the line if we wanted to. So this will usually give a hacker 10 to 15 results that are good that he can start looking into and start trying to dig into and go from there and see if there's information that they actually don't want you to see.
So like the actual subfolders in a website, I mean, there's a lot of stuff that's accessible, but there is no way to navigate unless you guess folder names. But given that there's so many standard names used, Dirbuster, GoBuster are going to expose a whole bunch of files and folders in most websites.
Yeah. So part of it too is not just, it's not that people use like default names just for the fact that they're lazy or anything like, or bad admins or anything like that. It's also, you've got to understand, if I'm trying to log in as an admin to that website, right? Well, if my login page is just a bunch of random characters, I have to know that, because I have to try to log in the future. So having a admin login as the page name actually makes it very easy for the admins and for future people, right? Because let's say you're the web designer and then you leave in 2 years and no one knew that you had a back door into that website and it's named, 1, 2, 3, 4, 5 or something, something crazy. No one would ever find that. And then if a hacker does find it, you don't even know it exists. So having those back-end pages and things like that be default names isn't necessarily out of laziness. It's also out of a standardization that is almost necessary.
Yeah, you want to help other people understand the website.
Exactly.
That's very much in the interest of the website owner or company or whatever.
Yep.
So we are. So now we're in super secrets, and in the super secrets, it was revealed as hidden in the text. And have you? Yeah, you've solved.
I showed that. Yep.
Cool.
All right. So now we're on to power cookies. So we've done some cookie ones in the past videos. And if you've seen those, you'll see that this one is way easier than those.
Yeah.
I didn't even see, let's see what the hint says. Do you know how to modify cookies? So that tells us right there what we're going to do. you can actually, if you wanted to, if you've seen in the previous ones, we've used Burp Suite. You could use Burp Suite to do this as well.
There's even an extra hint, like continuous guest. So like your guest,
yeah.
you're not, yeah.
Yep. Yeah. So you know when you're changing cookies, at least in CTFs, typically we're trying to become admin, right? I will say in real life, you're not so much worried about being an admin. Yes, that'd be awesome to do, but you're just trying to impersonate somebody typically or take over a session. Now, granted, if you can do that with an admin, it's 1,000 times better. It saves you a million steps, but typically we're just looking to see if we can do it. So we apologize, but we have no guest services. Okay, so that's another hint. It tells us there's nothing for the guest. So let's go ahead and see what the cookie says. So when you go to inspect, you can see, obviously these are all up here. Under application, you're going to see cookies, and you see they have a cookie set here, and it says is admin. Now, if you guys understand the value 0, that is basically false, is what that stands for. So we need that to be true, which would be 1. So if we change that to 1, it now asks, are we admin? And the answer is yes, we are. So now if we refresh the page with that cookie changed, boom, now it has something for us. It has the actual flag.
Fun fact, 1 and true and 0 and false are interchangeable in every programming language that I know. So I don't know if there's a programming language where you can't say like, you can't use 1 and 0 as Booleans, except like if you set it initially, like it's like in Python, if you said, you know, game on equals 1, it would like treat it as an integer though. So like you'd have to, in dynamically typed languages, you have to actually create it as a Boolean, but then you can use 1 and 0 instead of true or false.
Gotcha. Yeah, the only one I could think, the only programming language I can think of that doesn't follow that standard was probably the Rockstar one that we did in that other video.
that was done.
All right. So that's Power Cookie. That one's pretty easy, especially compared to some of the other cookie ones. The last one is SQL Direct, and this one, this one's not really a challenge as much as they're just trying to get you to use PostgreSQL and understand it. So let's see, we got to pop this out and then we'll get this going here. SQL Direct. So this one does require you to start this instance. So make sure you start that or else you're not going to get this little information here. The hint, what does a SQL database contain? And it contains, I'm assuming what they're looking for is tables. I'm not sure. I'm assuming because that's what we have to do here. But first, let's log in here. All right, so load it up. We're in. So they tell us the initial command, and this is a pretty basic command. It's PostgreSQL, and then it's the actual website, which is just Saturn PicoCTF net, then the port, and then the Postgres Pico is what we're going to connect to. So we'll go ahead and just paste that. Go ahead.
In like as somebody who hasn't really used much SQL, SQL is a database, sort of a database.
It's just a database language. Yeah. It's not the database itself.
Right. And there are commands that basically, for the most part, query the database for information.
Yep.
Now the sort of syntax of connecting is a bit like netcat. So there's a port. What does -h stand for? If TAC H.
So what we can do, and I'll just exit this, and we can just say PSQL. Let's do this. So this is the man page for PostgreSQL. So you can do this on any Linux. This is when we had that discussion earlier about a lot of the different programs or scripts that we've been creating. When you get someone that creates like a very good tool for hackers, they will even include a man page. So that's where I'm saying they flush them out completely. But these will tell us exactly what the command does over here. So let's look for the H, and you see that's the host name.
Right.
So there's the H, that's the host name. And then the P is obviously port, right?
Mm-hmm.
And then the U, I'm assuming, is username. Yep. So there's our username, which is Postgres Pico. And then the password is just Postgres. So that's an easy way to, if you're ever curious about these, how to find that information. You just type man, which stands for manual pages, and then whatever command you're doing. So now we can just go back, and the password is Postgres. All right. So then one thing I know in the one of our previous videos, we did a SQL box, but PostgreSQL is slightly different. So I wanted to pull up a cheat sheet here. So we'll go ahead and keep this.
Do you want to send me the URL in Zoom, and I can try to make sure the thing's included in the sweet. Let me clear drawings.
Yep. And if you guys don't want to look at the description, it's literally postgrescheatsheets.com or cheatsheet.com, excuse me. But basically, this is just telling you very basic commands on what you're trying to, depending on what you're trying to do. Well, we know we need to see the table, and you could go to databases, and because we're already connected to the database, so we don't need the database name, so we don't need to query anything. We need the table, right? So you can see it's going to show you the table, but you need the table name there. So we need to list the tables. So here we go, list tables from all schemas. So that's what we need. And this says list tables from current schema. So let's try that. We need to find the tables. And that's what, so if you guys don't know how SQL databases work, you'll see it here. You see here, there's a schema. The schema is the entire piece. It's everything together. And then from there, you'll have tables. Well, tables will then be what's actually holding your data. And then you'll have columns and rows, which will be like this name and different things. So you'll see the schema's name is public. The name, or what's inside the schema, is the names. And looks like they only have one thing, and it's flags. And that's the table name. So inside there, there'll be rows and columns, which we'll see here in a second. So from here, we're trying to open this name of this table, which is flags. So we need to go ahead and say select. So this is a very common, you'll see this in all SQL languages. You'll see select. That's where you're actually grabbing the information. So we're going to say select. And then if you remember from our actual SQL injection, we're going to do the star, which is select everything. So we want to see everything. And then we want to see it from the schema public. And then dot flags.
Dot flags, yeah.
And that's going to say, we want to see it from the schema public, the table flags. And then every SQL command ends with that semicolon. We'll hit enter. And then you can see this is how an actual database is set up. You have different rows and columns. So the ID here is 1, 2, 3. And then first name, last name, address. So when you set up a database, you select all this, what you're going to put into it. So you could change this instead of first name, last name. You could say, last name, first name. Instead of address, you could say, I want their phone number or whatever else. And then it's going to store that as the identifier for that. So you can see Luke Skywalker's address is the flag for us. So perfect. And then it already copied for me. And boom, just like that. So this one, they just wanted you to actually get familiar with SQL, I believe, and kind of understand how connecting to a database and pulling data from it exists.
Cool. Very cool. Do we have any more from your end on the web exploitation?
Nope, that's all the web exploitation ones.
Cool. All right. I think I better log into Pico and line mine up. See you guys in one sec. All right, let's rock and roll. So the challenges that I'm going to be doing are all from the cryptography section of PicoCTF 2022. So if I go into 2022 and cryptography, here they are. All right. And we're going to start from the beginning. Let's see what happens if I do that. It's probably going to be scrollable. So cryptography, PicoCTF 2022. And the first one was basic mod. So it's kind of fresh, like only a couple thousand solves, right? So basically, here's what it says. We found this message being passed around on the servers. We think we have a working decryption scheme. Download the message here. Take each number mod 37 and map it to the following character set. 0 to 25, the alphabet uppercase. 26 to 35 are the decimal digits, and 36 is an underscore. So I just basically did that, index 0, did the alphabet, so that's the first 0 to 25, and then 26, those are the decimals, and then that's the underscore. If you did this at home, that'll take you 5-10 minutes. The other thing that, go ahead.
Sorry, just because I know encryption, I wouldn't know this based on my programming skills, but can you explain what mod 37 means for people?
Oh, I will in a second.
Okay, perfect.
So I'm just gonna also get the message, and here I'm in a website called Replit, which just is like a Python online interpreter. So it's actually a full online IDE with some folder structures and whatnot. So I'm just gonna copy the link and I'll wget the message, and you're gonna see it appear over there, hopefully. Yeah, you're asking me which wget to use. So if we get the message, I'm just gonna make sure that I'll print it here. So that's the message.txt. Essentially, that just opens the message, reads the message. I will print the message in the, that's my main.py actually. So yeah, I'm going to print the message right here. And that's the message. It's a bunch of numbers. Like, to me, if it was up to 255, I'd be like, yeah, these are ASCII characters, but we're gonna find out how they could map to that. And to do that, you're using the mod operator. So like if I wanted to do, let's say 10 divided by 4, right? I would get 2.5. If I wanted to do that without remainder, like floor division, that would be 2. But if I did 10, I always say percentage, but 10 mod 4, that would give me the remainder of 10 divided by 4. So what's the effect of having 30, mod 37, right? Pick a number, Stuffy, like any one of the ones you see here.
Let's do 54.
54. So if we mod 37, like the remainder has to be a number between 0 and 37. And that's very useful because we got about 37 characters. So when we mod that by 37, we're going to get 17. And we're going to get a number between 0 and 36. And guess what? Our indexes are 0 to 36. So like every one of these numbers is going to map to one of these things, right? So that's really...
So just for people that, just because I'm very bad at math, I just am good at cryptography. So I know if I was looking at this and don't understand cryptography, I would have no idea what's going on. But basically, if you guys don't understand what he's saying with the mod, all it's showing is if you took 37 and put it into 54, right? It only goes once. So what's the remainder? So when you do regular division, you'll get 1 point something, but the mod is just the remainder. So it's a way to change it basically with just the remainder of it, not the actual result. So don't worry about, obviously 54 divided by 37 is not 17. It's just the remainder of the division.
And so look, at this point, we got to find the numbers here, and we're going to then map out, they're all going to turn into some number between 0 and 36. And then we're going to map them out to this. So the first job we have, I'll print the message again. I don't know why I'm printing it twice. I should be printing it once. I'm printing it twice. This is weird. Oh, because the message is probably 2 lines. I'm printing it once. It just, no, there it is. It ends at 70. Yeah. So what I want to do is simply, read off these numbers. And that's not that easy or that hard. So like if I go for C in message, so like for character in message, print character, you're kind of going to see that like we're going letter by letter. And I mean, these numbers that are in the message are essentially text. So like I got to chop up the message a little bit, and I could turn that into a list. Message equals to message dot split. And this is going to look like we're there. Let me close this. And now like that's the message. Look at that. So the message is a list, but you notice that they're still in quotes. So these, I can't do math. I can't do math on these. If I mod them by 37, I'll get some kind of an error because the numbers are still strings, right?
Yep.
So let me run that. Yeah. So you can't be, you can't do it with strings. But so I got to basically do that as, if I did that as int C, now that basically that's going to be the flag right there. So perhaps it's worth just sort of formatting it as like, you know, decrypted number, decrypted, or maybe even just really break this one down. From the next one, I'm going to do it a lot quicker. So like num equals to int C. And then we can make the encrypted number num mod 37. And then we can print encrypted num. So if this prints out the same thing, I can just print the character in a second. No. And instead of printing the number, I could just now take that number to be the index of the alphabet, right? So like the first one, we're going to start with 17, and that's going to be somewhere here. It could be a U, and the next was 26. It could be a O or a Z, or let's find out. So alphabet of encrypted num. Oops. And I'll stop printing the message. I don't need to do that anymore. And there you go. That's the round and round. That's the flag. And how do you solve it? I guess you could just do a solution. You could use a dot join, but this is nicer. So you just create some string, and then you add to it there. And then when you're done, you print solution. And this is what you get from using an online IDE. Sometimes it's not perfect, but there's your flag.
Perfect.
Yeah, it's essentially Python data manipulation at its fairly basic level. But I try to make a point of like doing it in more steps than necessary. Like I could do this in one line. I could do most of this in all of it in one line, actually, but that would make for code that I find it much harder to explain to people. So
see, and it's funny because the way you did it is similar to the way I would have done it, right? But like, for instance, the solution equals, print or quotations just to add that little bit of niceness to it. Like I would have left that out, and I would have just said, okay, well, I can read it up and down. I can do that. Right.
Right.
But mind you, if the character's 500 characters, now we're going to have to, do this type of thing. So it's just interesting to see how for you, it's so fast to come up with that solution as far as making it look nice.
Again, like this is sort of what Python's really good for, right? I mean, if I had to do this, if I had to do this in JavaScript, you know, this would take half an hour because I'd have to look stuff up as well. But
Yeah.
okay, so let's look at the next one, right? And I might just sort of delete this because people would probably go and try to solve the second one after they did the first, right? So like, don't worry, I'll paste the solution in the description of the video. So let's just say here, we've done the first one, and the second one defines it a little bit different. We're going to have mod 41 and then find the modular inverse for the result. I had to Google this. And it's a new message. So let's begin with downloading this new message, wget copy link address. So it's similar, but there's a bunch of differences. Let's just take a quick look at the message before we move on. It's the same type of thing, at least in the message. Take each number, mod 41, find the inverse. Aha, and look at this. The characters set 1 to 26 instead of 0 to 25, right? So you, like, if you go here, yeah.
Yep.
So, I mean, everything's going to be like, they designed it on purpose like that. So everything is one off. Like if you're not paying attention, you're going to, so now it's like everything's been shifted, right?
Yep.
All right. So we got 1 to 26. That's all the same. And then wrap your decrypted flag in the PicoCTF flag format, right?
Yep. So,
you know, this one spun me around a little bit, the whole modular inverse and what is it? And so let's see what happens. Like if you just go modular inverse Python, immediately the Stack Overflow page comes up and it says, somebody asks the question, and then there is this POW function, like Python 3.8 plus 197 upvotes. Okay, POW. So then if you go and search for POW Python, it explains it pretty clearly that like, these are the parameters. This is the number, X is the number. So like, maybe like in our case, 150 something of the message. Y is the power. Inverse is just the power minus 1. And Z is the modulus. Great. So instead of like our number percentage 37, we're going to have our number minus 1 and 41. And that's all there is to it. So now going into this message, I'm just going to double check, print that we've like split it, right? Clear. Why is my reconnecting? Okay. Oh, it has a solution according to the old one, but oh, print message. Let me just sort of do this thing from scratch. I just want to see that this is a sort of list of numbers. Yeah. Okay, so we got, so now, I mean, for, I guess, you know, number in, it is a number, but it's a string number, num equals to int. And we're going to perform this inverse. And it's going to, so like we've got our num. So what am I going to call it? Decrypted num, decoded num. And that's going to be the POW function of our num, remember. And what are the parameters is -1 for the inverse. And they said mod 41.
Yep.
Okay. So I'm a little bit, I don't know what inverse does, but like this is going to be decrypted if I get a series of numbers here, I'll get rid of this message. If I get a series of numbers between, 0 and 37 or whatnot, that means like that's very good, right?
Yep. Yeah, because it can't go over what, 37?
Yeah. Because that's our alphabet. And so like I'm pretty confident that I can just go now solution plus equals alphabet and a decrypted num. So that's the modular inverse. I mean, this is like 2 quick Google searches.
Mm-hmm.
And, the biggest problem we've had with this is Replit. Invariably hard. Not really, but thanks. And like modular inverses, I had to Google it. I mean, when multiplied. Yeah, I hadn't even read the hints.
To use a tool. So they wanted you to use a specific tool instead of even use Python, huh?
I don't know.
Or maybe Python is the tool.
Python is the tool. Like the POW, it's again, like everybody's, I imagine you tackling this using some type of like hacker tool that works in Linux. But for me, this is like,
I probably actually would have done this one the exact same way you did, as far as I would have looked it up, because I'm familiar with modular inverse, but that's math that's above my head. So I could never tell you what it's actually doing. It's the same as when you start getting into cypher blockchaining and things in cryptography. I understand the concept, but to do that algorithm no one can do that in their head.
No, like you do it by by trying to plug in conceptually the easiest numbers to understand. Like I did RSA encryption, and if you plug in, I don't know, like very, very easy to process numbers, you can you can get the math.
Yeah, you could do like a small little byte or something and XOR it and then use a initialization vector and things like that. But I mean, once you start getting into 16, 32 rounds and everything else, it starts getting very mathematically difficult.
Yeah, to even imagine. All right, everyone, we are jumping into Kali Linux for the cred stuff because I wasn't able to unzip a directory inside the PicoCTF web shell for whatever reason. So this challenge called cred stuff gives us the following. There's been a password leak. These really, really do happen. And it's been leaked probably on the dark web as a tar directory. And it's going to have usernames and passwords. And we're going to try to unpack this leak and see if we can figure out the password of this user. So we wget the leak. Good start. It's there. And now we're going to unzip it. And I think the command is tar tac tzf. And then let's see if it auto completes. Ooh, it's not. I'm worried.
There's not.
XVF. Let's try.
I was just thinking that for some reason.
And there it is. By the way, I'll try to attach this. This was the kind of how to extract and zip. And there's a lot of variations. And the one like when I was scrolling down, I just saw CVF and XVF. where tar, not tar.gz. So my understanding is, and not that I've used it much, it's basically the same as WinZip or gzip, and tar is like a more Linuxy way of zipping files. Is that right?
It's similar. There's also other ways, like gunzip is what I typically use, which is just another tool. I mean, there's a lot of tools out there, but tar files are pretty much the same thing. It's very similar.
So let's see what's in the leak. Passwords and usernames. And if we cat passwords, cat passwords.txt. I mean, can I even scroll to the top? This is something like thousands and thousands. No, I don't get to the, I do get to the top. So that there are thousands and thousands.
Eventually.
Actually, I'm maybe going to say a couple hundred. So there'll be a couple hundred of entries there. And if I cat usernames, it's going to be there. And so I have a question for you. I mean, would you be able to find which line is like, if we were, is there like if we were to grep for the specific user Kaltiris, right? Of course we would find it. Grep Kaltiris in usernames. You would find it. Is there like a grep which tells you on which line?
So there's an even easier way that I don't know. I don't use Kali that much anymore, but if you just open your text editor and open the file that way, usually they'll list the lines will be numbered in your text editor typically.
Oh, that's actually not too bad. So I can, I solved this, of course, with a Python script. How do I open it with my text editor? Is there some sort of like
it's the text editors at the the text editor's at the top right next to Firefox. To the right of that. Yep, right there. Yep.
No, to the left, this guy?
Yep. Nope, that one right there. Yep.
This one.
Yep.
And I guess I need to go find the.
There's other ways too, and I can show you how to do it.
But no, I was going to say, is there a way to run the text editor from the command line? Probably is. It's just.
Yeah, you just need to know the name of it. It's called Mousepad there. I didn't know which one came by default, so I was.
What's this one called?
Mousepad.
So Mousepad, and then user. And it does number them. And then if I control F, cool, T378. All right.
That's usually the easiest way because of how many results, but there is, I mean, you can easily do like cat with a tac in, which will number the lines and then grep it. And that'll do.
Oh, silly man. I'm functioning on less sleep than I should. And I'm making rookie errors, but okay, we just go to 378. And that looks like, that's a flag right there. Look at this.
Yep.
So, I mean.
And even if you knew, so I didn't actually expect the brackets in there with the flag, but even if you knew those brackets were there, you could just search for those brackets and you'd find it right away.
So, how would we do this? There is, I guess, Cyber Chef. We could just go there and do the magic on it. But funnily enough, I looking at it, everything is alphabetical, right? And everything being alphabetical, there isn't enough information for a substitution. The only thing it can be some sort of a Caesar cipher, right? So I'm just going to paste it here. And I'm going to say Pico is going to be in. And this is sort of silly because nothing like that. That's ridiculous. Caesar cipher breaker. And then I've written a Python program to break Caesar cipher. I might and I've done this many, many years ago with the crypt brute force. And of course, there's going to be a PicoCTF in there somewhere.
Yep.
Do you see it?
Not yet, but yep, I do. Number 13.
There we go. All right. So, I mean, that was easy. There is, again, this might be a little pause. Let me just search my REPL account. If I have my Caesar solver in here, because it would be kind of worth putting it in my little resource kit for the viewers. Guys, you really should open the description of these videos.
Yep. And if you guys don't know what the Caesar cipher is, it's a very simple cipher. All it is back in the day, Julius Caesar supposedly used it, but all it is moving. It's a substitution cipher where you're moving based on a code. So for instance, if the number's 10, A would then be, you'd move to the right 10 places. So it'd be A, B, C, D, E, F, G, H, I, J, K. So then A would be K. And then the other person would have the code of 10 and they would just reverse it. And it's a very simple cipher.
Okay. I've got, this is ancient. Like even this was one of the first, like, I think this was when I taught year 9, and I don't know if I can get my, but yeah, this is the decode message, and it tries brute forces everything. And I think it's only like an extra couple lines that recognize English words. So yeah, I'll find a program and I'll include it in the list of solutions. All right, Cryptography, Pico Mini, was that credstuff?
That was credstuff, yep.
And we're going to, I think we copied out the flag. Boom. Awesome. Morse code. Yeah. This was like, I have no, like, I could either learn Morse code or just download it. I mean, hints. Audacity is a good program. Dudes, there you go. I didn't even need that. I'll show you what I did. You Google Morse code audio decryption. That was my Google. Adaptive decoder.
Nice. See, this is an interesting one because this one, like, I guess I get you're trying to mentally get people to think about it this way, but I would personally, I've never seen someone actually use Morse code for actual sending of messages.
So this is the message. Look at this.
Oh, nice.
What?
It goes through the whole thing. That's neat.
And it decodes it live. I'm having to like turn down my headphones.
Oh, okay.
There we go. And so that's basically the answer. Now, when I wrote PicoCTF here, I figured I'm going to need underscores because like every flag I've ever seen had underscores and no spaces. So that was something I added.
Perfect.
I solved it correctly again. I don't know that, like, I didn't feel like I was going to learn Morse code for the sake of a PicoCTF challenge.
Yeah.
There's already algorithms that do it. So just use the tool, guys. I reckon. Yep. Anyway.
Yeah, unless you want to learn Morse code.
Yeah. I don't actually know anyone that knows Morse code. Like,
I know a few guys in the military, but that's
I was gonna say, I know you're in the military and like you're in the sort of tech side of things. So if anyone's gonna know it, it's someone like you, but you don't know it, right? Some of your
No, I know some guys that do, but it's just I won't ever need that, I hope.
All right, Stuffy. Here we are. The next one is called the rail fence cipher. And what it starts off as is giving you this article. And it's just a way of encoding text like this. So the rails, the number of rails is sort of the height of this. And you will notice that there are 2 characters on line 2 for everyone there, right? So effectively, like if you've got, there's a mathematical formula for this, but I'll tell you the math behind it. In principle, you have twice as many characters in the middle as you do on the top or the bottom. If your rail was to have 5 or more, then you'd have to use the formula, but we got rail of 4. So we're really got to take the string or whatever the cipher that's going to be encrypted there and break it up into like pieces that are 1 piece on top, two in the middle, 2 in the middle, 1 at the bottom. So we'll take the message, copy link address. I might just open the web shell here. Or no, actually, forget the web shell. We're going with Kali. So rail fence will doubly get that. And there it is. And if we cat, that's our message. So we got to figure out how long this is. So if I copy this text, I wonder if I do this on Python 3 len. That should work, right?
You just missed a parenthesis.
Oh. Why are you doing this to me? Unexpected token. Sure. Nano. $56. So I wonder, would this work in Bash? Like 56 divided by 6, will it give me something? Python 3, what about now? No, I can't do it. So like it can't execute. It's not like a REPL command. So 56 divided by 6 was 9.33333.
Yep.
So what effectively that tells us is, and I'm just going to use a little spreadsheet here, is that the top row is either going to have 9 or 10 characters, right? So if we break it down into 1, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going to need to add some more rows. With 10 characters, we should be able to begin breaking this railfence cipher. Now there are automated solvers, and I don't know, for whatever reason, I'm attached to the idea of trying to solve it manually. But yeah, if we go into this and we start going character by character, TA, that's a space. That's a 7.
Oh, underscore.
Oh no, that's an underscore. Yeah, this is underscore. And
Now 7.
Oh, 7 and 6. Now, I'm not going to go through this whole thing. But if we were to do it character by character, going like this, the cipher would read like a snake. You would go down and up and down and up and down and up and down and up. And whether we're on the right track is literally going to be told to us by Rail cipher solver. And it was a decode.fr text. And by the way, that was our text. I think our text I can also see because we catted it here. Copy selection. I know that that's not the safest thing in the world to allow copying and pasting from your virtual machine. So if we specify for, we decrypt that and decrypt the rail fence, it's going to say the flag, da, 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 da. So the flag is that where does the fence begin and end? So it was TA dot. Interesting what happened to that space.
It looks, yeah, I was gonna say, it looks like they added that.
The space is converted to a dot and then 7, and so it starts off correct. TA.
No, it's still correct because that's the
Dash.
space, then the underscore.
Space
We just-
underscore. Yeah.
We just don't see it go past that.
We don't see it go past that. So it's a very sort of tedious thing unless you can get an automatic solver. We sat there with a previous attempt at this, and I estimated like 30 minutes if we're lucky. So yeah, I'm just going to copy the solution here and see, going to PicoCTF and PicoCTF curly brace.
You missed the F, just heads up.
I've missed a lot of letters today. Submit flag, rock and roll.
Perfect.
All right. So that was the rail fence. And talking about the next ones, substitution cipher is also known as a visionary cipher. We're going to jump into these, but these are actually one of the most common old ciphers. And the whole idea is that one letter maps onto another letter in the alphabet, right? And so when we download the message, copy link address, if I was to, all right, let's just go in here and we're in the rail fence. So why don't I get out and make a directory, and we'll call it sub1. And we doubly get this message and ls cat message. If you notice, like everything in this message is letter for letter, letter for letter, letter for letter. And look at this, look at the bottom, look at the bottom of that, right? So again, if you are inclined, you can try to solve this manually. There's like a semi-manual solution tool.
You can tell just looking at it too. So this is one of the biggest problems with substitution ciphers is letter frequency. So like frequency analysis, exactly. So like I could tell A is probably U just by looking at that, because there was a lot of single U's, which mean that that's probably A.
So if we were to try to brute force this, it might take, I mean, it's something like 26 prime, right? Combinations, like it is 26 times 25 times 24. Yeah, that is maybe too hard to brute force. But with frequency analysis, English has, you know, some letters occur a lot more. It's like ETAOS, ETSAO, ESTAO. So some letters occur a lot more than others. And if you account for frequency analysis, then like the number of possibilities shrinks a lot. So there's brute force solvers that I could literally paste this into, but we're not going to do that. We're going to just start. I want to start solving this. I want to paste it here and just fix what we know. Like that's going to be PicoCTF. So D is P. F is I. I no longer know the alphabet. Q is C. Pico. Q. Wait. Wait. Oh, Oh, okay. So Q is C. That's, yeah, it is PicoCTF. A is T. N is F. Now, if we start substitution, okay, I misspelled something here because on that last line, let's see, D is P, D is P, F is I, Q,
C,
Q is C, O. Oh my God, is O O?
Yeah, O's O. And to be honest with you, just going off what we've got, we could probably finish it out because the L, that first three letters is probably the flag is because it starts with an A, which is a T.
Yeah.
Yep.
L is H. And R is E. And oh, he, R. I reckon that has to be, oh no, there's one word, hell. I still don't see PicoCTF in it. So it's like, I feel
It would
like,
be down at the bottom.
It's at the
You've
bottom.
got the whole thing. As I say, you get the whole thing in there. So
okay.
Yeah, it's the flag is PicoCTF and then.
Okay. So this N is F. Oh, we already have that. J is L. U is A.
And you guys could do this manually. I mean, it would take you forever, but you could do it manually just by, if you write this down, you know it. Every time there's an instance of A in there, you put a T there and so on and so forth.
And as you can see, the flag is, and we already got like half the flag. So that's how you do it manually. The encrypted text, there are many tools that will break it. Okay, so now we're going to basically take the text and put that into the auto solver. I might have said visionaire is substitution. That's not correct. Substitution is substitution. So like if I just Google substitution cipher solver, this Kubala text, this is probably one of the better ones, although there's like a dozen that work. I'm going to just copy the message.
And the reason this works is because we are using a monoalphabetic, meaning we're only using one alphabet. So it's pretty easy to look at breaking the analysis with frequency.
There you go.
Yep, there you go.
Hereupon. The reason why the other text is necessary is because if we just put this in, this isn't really text. So like it wouldn't be able to auto break this. This isn't in any dictionary. So yeah, that's our CTF flag. Boom. And in the second, I did what you do. Like I didn't actually enter the flag for once. And in the second, I mean, we effectively, if we copy the link address, we're effectively going to have, we're going to have the same thing. I think it's going to also say message.txt ls. So we're going to have to cat.
Okay, so they took out
they took out all the punctuation.
Punctuation, but you can still see where the flag is.
So again, you gotta copy selection. And if we pasted this there, and
again, you guys can break this down yourself based on showing the flag alone.
Uh-oh, this isn't going to work. So This clear text maps to this cipher. This is weird because
Mhm.
like I must have reopened the. Well, I think we're just going to need to paste it here. Is there a substitution cipher solver, no spaces?
The big thing we're looking for is just frequency analysis, because it's not going to be able to break the code. It's just going to analyze it, and then you can try. It might be able to auto solve it. There's just several other well established. So yeah, they've got it pretty good, but there's different ones if you notice.
And
so there it is. Pico machines. The flag is PicoCTF NRMNY. So the letter or the numbers are the same because there is no numbers in this alphabetic substitution. So
I'm just like, I'm having a hard time reading. There exist several well-established schools of computer. This is good. But the frustrating thing is,
they put it on. They didn't put the
numbers are spaces.
Numbers in there. Yeah.
So like we would need to, but this is the alphabet.
It's just N6RM or N6R4M underscore 4N. Yep.
If we go options for auto solve, iterations, max results, spacing mode, dictionary weight, automatic. Rearrange, keep existing, substitute, options for auto solve. Like if we did
I'm not
rearrange,
sure what that'll. Yeah, I'm not sure what it'll actually set it to.
I mean, that's going to look better, but the numbers are still numbers are still going to be gone. So we have a tool that does it. If somehow I could add instructions, if somehow I could keep the numbers, I mean, I guess we can just, I'll pull out the here and we can work it out.
Yeah, I mean, we can just copy and paste it, and it's pretty easy.
Actually, that's not the worst idea. Oh,
there you go.
Oh, is it? Did it paste well at all?
Of course not.
If you pasted it in a Word with certain settings, keep text, merge formatting, keep source formatting, nothing. Doesn't.
We could even just type it out. I mean, it's pretty short.
PicoCTF.
Bracket.
This is N6. All right.
Yep.
It should sort of read out something, right?
Yep. N6 R4M underscore 4N 41 Y 515 underscore 15 underscore 73 Delta 1 D. Sorry.
Oh.
D1 0 U5 underscore 6 CDAEA 76.
If this is,
and then bracket. So it says analysis is serious.
Analysis is serious. All right.
Something analysis is serious.
Oh,
perfect.
man, that was, that was harder work than I thought. And there you go. That's Visionaire. And between now
No,
and the next,
that was substitution too.
yeah,
Or
the
one,
next,
one, sorry.
the next, no, we did, oh, yeah, we did 0, 1. What was 2? I mean, let's,
That was 2, the one we just did, because it says now there isn't any punctuation.
right. That's what confused me because I had done 0 and 1.
Yeah.
And copy link address. So we did, just for the sake of it, I guess we're definitely gonna go into the substitution solver and get that last one. Why not? So if I get this guy, and then I ls it, it's going to be message.text.to. So cat message.text.to. And that was, yeah, that was like why the no spacing just threw me off, right?
Yeah. So this one, they just take out the pronunciation or punctuation, but they don't take out the
and
the spaces.
In this Bookcentrics tool, like it was actually really, really good, but it doesn't paste well. So like if we go back into the gubala.de, maybe we're going to have a little bit more luck. Not German, English. Even though we picked German, it was still
found it. It says frequency attacks are cool.
Frequency attacks are cool. There's a J instead of the Q, so it might not. Yeah.
There we go.
That is the 3 substitutions done.
Yep.
Yeah, my apologies to you.
No,
Stuffy,
I didn't notice it either.
And the audience, I think like with generally ciphers and encryption, things can get pretty tedious. Okay, this is going to be, I reckon, the place where we officially wrap up. So thank you, everyone. I hope you enjoyed the solutions to the PicoCTF challenges. Especially, I think Stuffy's in the beginning were a little bit more coherent and organized than mine, but you can basically tell with encryption that the more you throw at the wall, some of it eventually sticks. And there's a lot of tools online. Try to take advantage of those. And I hope that the lesson you take away is with all of these, it's quite important you learn how they work. So attempt to do them manually. And if you're on the right track, by all means, save yourself some time by using a solver. But initially, I think attempting the manual ones is a good idea. So once again, thanks a lot, Stuffy. And
of course,
see you everyone in another video.
Thanks, guys.